All right, so a student wanted me to go over problem number 99 in the calculus prerequisites pack, and one of the reasons this took me a day or a little over a day to get is I wanted to make sure I was working on the right one, because I did get some information that the last time I worked on them, I was working on the wrong worksheet, so I apologize for that. This time I'm going to be working on that right worksheet. All right. So, problem number 99. A population of fruit flies, initially numbering 100, becomes 150 in 3 days. We want to determine the population of fruit flies after 10 days. Now, if you think about fruit flies, they mate, they got babies, those babies grow up usually within about a day. Those babies mate, they grow up, and you get a number of fruit flies that keeps on getting bigger. Now, this is assuming no fruit flies dies, but because we have the fruit flies, they add some more, and then all of them keep on increasing. That tells us that this is an exponential growth. So that's the very first thing we want to make sure we use. This is an exponential growth. Now, if it's an exponential growth, then we can just use one of our basic exponential functions to go through it. We have our beginning principal or beginning basic value times a constant rate that it's multiplying by up to the number of time, our unit of time, up to the t. So we're going to be using that type of equation, and that gives us the total value at any time t. So using that exponential growth equation, we can go ahead and fill in some stuff, see what we can find. We know that the population numbered 100 at the beginning. That tells us what our p is. It's 100. And we know that it becomes 150 in 3 days. So we know that it's going to equal 150, and that's after 3 days. That's our unit of time. So we got 100, but we're not going to multiply this times r, or we're not going to multiply it by anything specific. We don't know what that is. We're just going to call that r. That's the constant ratio. Okay, so now all we need to do is solve for r. If we can get that constant ratio, we can find out how many after 10 days, because this equation will work for any number of days. Again, provided that no fruit flies die, and we assume that they keep on multiplying. All right, so in order to solve for r, we would just go through the usual process. We're going to divide both sides by 100, and we get r cubed is equal to 3 over 2. When you simplify it, 150 divided by 100 becomes 3 halves. And so, finished solving for r, we get r is equal to the cubed root of 3 halves. Now, you want to get the cube root of 3 halves, you could also write it like this. It is 3 halves to the 1/3 power. And that's the way that I like to write it. It's just usually a bit easier to write that than trying to find specific roots. And so that's what I'm going to do here. Parentheses, 3 divided by 2. Put that arrow there, close those parentheses, up to the 1/3 power. And whenever I've got that, hold on just a second. I just realized something. Is it 3 days? Or is it 2 days? That's an interesting question to ask, and we'll talk about that in just a second. All right. So we start off with, we finish off knowing what our ratio is. 1.145. Okay, so that's our constant ratio. Now, whenever we take that to and plug that in, we end up with our 100, and I'm going to change colors for this. We end up with 100 times our rate, which is 1.145, to the 10th power because we want to find out what it is after 10 days. And that gives us, let's find out. All right, so I'm going to put this down and write it down as our R, and I'm going to put R equals. And that way, I guess I can't use R. Let's use K. So K equals that, and let's just plug this in. 100, and instead of using, trying to type in that number, I'm just going to type in K, and then I'm going to take it to the 10th power. Okay, and then I got 386. Okay, 386 different animals. Now, if you go to the solution, I believe the solution doesn't actually say that. It says 99, it should be 385. And then it says the K is 1.135. Our K is just a little bit off, but our final value is actually pretty much correct. It's 386. It's one higher. So why is that? Why would it be just a little bit higher? And that goes back to the question that I was asking a little earlier. What about that R? Specifically, that 3. I chose 3 because it says it becomes 150 in 3 days. But if this is our initial value, wouldn't that be on day 1? And this is on day 3? Because we had, whenever I was originally writing it, I was considering it to be day 0. But whenever you think about fruit flies, you don't really start at day 0, you start at day 1. And so if we change this around, just to see a little different values here, 100 times R squared, because from day 1 to day 3 is 2 of them, equals 150. And so that leads us in the same way that R is really equal to the square root of 3 halves. Let's check that out. What is the square root of 3 halves? And so whenever I look here, I just have to put it to the 2nd power, 0.122. Okay, and then plugging it in, that would give me a huge amount. That definitely does not seem right. So the way that we did it is correct. It's just the solution in the bottom of the equation. What it says for the K, or what we're thinking about is that rate, the constant ratio. That K is a little off. And the final value could be changed just because of rounding. With that said, I'm going to bring this video to a close. Hopefully that answered your question. We did a little extra experimentation here. This isn't part of the solution. It was just thinking, well, maybe that answer is correct, just trying to find it a different way. And it didn't work out. All right, with that said, I will bring this video to a close. Hopefully that helped you with all you could do.